Hi, my name is Ryan Ross, and this is Maximum Uptime Cluster Orchestration with Ansible. I work as a site reliability engineer at DBT Labs. But today with this talk, I'm not here to talk about DBT or DBT Labs, but my experience as an engineer working with Ansible and Scylla at a previous company that was a marketing DSP. So my talk objective is to provide actionable tips and patterns to build confidence in orchestrating ScyllaDB in production with Ansible. So here's our agenda, just to keep me a little organized. It's going to be, we're going to talk about the use case for Scylla at the DSP. I would like to define cluster uptime in this context with using Ansible. And then what you came here for, the tips on using Ansible ScyllaDB and the demo. Let's get after it. So ScyllaDB use cases. As I mentioned, this was at a demand-side platform or a marketing DSP. Wikipedia defines this as a system that allows buyers of digital advertising inventory to manage multiple ad exchange and data exchange accounts through one interface. Sound a little confusing? It is. So right here we have users at one end, internet users just trying to consume content online. And then we have agencies and brands that are trying to market and advertise and sell them goods and services. So my definition is going to be the DSP connected advertisers and agencies with audiences that allow real-time bidding and displaying of online advertising. So with those use cases, we needed a backend that could scale to billions of requests per day. We're talking about the open web here. We had equal read and write access patterns and accessing our data. We need to be up all the time. People are on the internet all the time. We need to be up all the time. And then we needed millisecond response times. Remember that crazy long graph? All of that stuff happens. There's a whole auction for advertising space and the media buying. All of that happens in less time than it takes for a user's browser to load a web page. So we need to be monstrously fast, as they say. And we need to scale to huge data sets. We're talking about the open web here. So we needed to be able to have a lot of data, but also access it quickly to make decisions. So, of course, Scylla is a perfect fit, and we love Scylla. So let's define cluster uptime in the context of, as an operator, orchestrating a cluster or multiple clusters using Ansible. So I would like to define for the rest of this talk to provide a cluster that is available for dependent applications, right? ScyllaDB by itself doesn't make our business money. It allows applications that are solving customers' problems and making the business money there. So we need to make sure that Scylla is up so that our applications are up and can do their job and solve real problems for our real users. So it looks like this. We could have a cluster, but then maybe this node has a problem. Oh wait, at the same time this node has a problem, but we fix those and then another node pops up and has a problem, and then maybe we lose that node entirely, and then we got to grow the cluster completely to just scale to demand. This entire process, as nodes are coming up and down, there was at least some subset of a cluster that was up and available. And if we can structure our playbooks in different parts of Ansible correctly, that is going to just help us provide the maximum uptime. So here's what you're here for. The tips for using Ansible to orchestrate ScyllaDB for the whole maximum cluster uptime. So the first part right here, Ansible has the concept, if you're not familiar, has the concept of an inventory. And that's just a way that we can structure our target machines that we want to communicate with. In this case, we can use DNS names. You can see ScyllaNode7.company.com. Or we can also use IP addresses down there at the bottom. Anything working on layer 3 will work for us to communicate there, at least service discovery there as well. And structuring our inventories in a certain way really provide us at the DSP with increasing our uptime. So what I ended up doing is I had one inventory per cluster. We had multiple clusters with multiple data centers in them, and having multiple Ansible inventories, basically these YAML lists of servers, helped us be able to differentiate which node belonged to which cluster, and we could apply different configurations to different clusters. Within those clusters, we had inventory groups. So we can see those right here. That's that little indentation in YAML. And here we can carve up our clusters even more. We had, you may be in a EMEA data center, US East, US West, and we can even apply different configurations to different data centers within a cluster. So once we define our declarative execution that we want Ansible to do, then we can have polymorphic behavior based on the inventory and the inventory group. And here's what multiple inventories could look like. We have our inventories directory, and then within that we can define any number of inventories that we want. Now you might be thinking, I don't want to have to manually manage these files, or our environment is so dynamic that we have nodes coming up and coming down all the time. A human can't keep up. As soon as we commit that version to Git, it's going to be out of date. I think an underused superpower of your cloud provider is going to be using them as an asset management database. Your cloud provider has all the information that you give it and more about your instances. And Ansible can tie into that API and use that metadata, and it's called dynamic inventory scripts. Let's take a look at an example. So here we're again defining in YAML, but here we are telling how to configure the dynamic inventory script, what project we want to connect to. In this case, we're using Google Cloud as an example. So the Google Cloud project, do we want a service account, how to authenticate, what zones to look in, and really what I want to key in here is these keyed groups pieces. So what this dynamic inventory script is going to do is it will look for any labels that you have put on your instances and build inventory groups based on those labels. So let's say we have Terraform, and this is part of what would be a Terraform configuration, and we are defining some nodes for us, and we apply a whole bunch of labels to those nodes. Ansible can build this file for us based on those labels, and in this case, we can apply different parts of execution against something that's, say, the US East data center, and it's going to provide that for us. So we don't need to know the 3 nodes or the 7 nodes, however many nodes you have in that data center. We just need to know, okay, this node, when it was created, it was labeled this, so therefore Ansible will make it a part of this data center. And we also get even more polymorphic behavior with this because in our other example, we didn't define an all Scylla group, or maybe an all production or an all service owner group. So using dynamic inventory scripts, we get a little bit more flexibility. What if we want to apply changes to all nodes that are a part of the component Scylla label, or all nodes that are owned by the US production operations team? We can do that with dynamic inventory scripts. The next thing I would like to talk about, and this will be more, we talked about the inventory piece. Now let's talk more about the actual configuration and execution piece. So we'll get to take a look at some tasks here in just a second. So Ansible has the concept of tasks, and we see a couple of names here. We have line and file, copy, and template. And you'll see examples of these here. So what we can do that you'll see a lot in documentation, a lot of examples, would be to use the template module, where you can take a Jinja file and you can and template that out with variable interpolation. So I took just the first few lines of a scylla.yaml config file and converted it into a Jinja template, and then which is basically those handlebars down there at the bottom. And so when I use the template module, basically what I'm saying is take this file, send it to its destination path on line 3, so etc scylla.yaml, give it some permissions, and oh, by the way, if you find any curly braces in there, do some variable interpolation and fill in what I want filled in there, assuming that I've defined Scylla cluster name somewhere else. And for most of the time, this would work great. It becomes problematic when we copy or template files out for files that are owned by the project. When you apt install ScyllaDB, you get that scylla.yaml file with it. But what ends up happening is that if you are creating a copy of that, putting in template variables, and then trying to template that out to your machines, then that means you are now the owner of that file. If that file changes from the upstream project, ScyllaDB adds new configuration options, or maybe they change something around. And if you're running on a file that you pulled down from 4.3 and now you're trying to upgrade to 5.0, you could run into some issues there. Line and file is going to help you with this. So it ensures that we have the most recent and valid file from the upstream project, and we only change what we need. We preserve project defaults. Here's what that could look like. So we have our line and file module within this task. And so think of the modules as like your standard library. It's just code that I didn't have to write that I can pull in and I pass arguments to it. In this case, down there, line 8, I'm passing in the argument, search for this string. So I'm looking for lines in the file that have this string in it. And line 7, I'm replacing those lines with this line. So before we had the brackets that could put in, say, EMEA production 2. In this case, we just need to replace only that line. So anything below that maybe doesn't change from the project and we don't need to change it, we don't have to. My next thing is more about on execution and run playbooks serially. This is something that we did a lot at the DSP. Remember, we have all of our nodes running and we need to be able to bring them up and down in a particular order. So by default, Ansible is going to try to run on a task on one at a time on all nodes in your inventory before it moves on to the next one. So here's what that looks like. So this is an execution of just some arbitrary tasks on 3 nodes. So we see here task 1, task 2, and task 3. And it tries to run task 1 on all nodes, and then task 2 on all nodes, and then task 3 on all nodes. For most things and most Linux deployments, this is probably fine. But let's take the Scylla.yaml example. To change that file, we need to restart ScyllaDB for it to take effect of those changes. Well, we can't just restart Scylla from the cluster without notifying anyone, because that could cause definitely some issues. So we need to drain the node first. So let's take if we have task execution, we need to drain the node, then update the Scylla file, and then finally restart the service. What we can't do is with default execution, we can't drain all the nodes in our cluster. That'd be a catastrophic outage. So we need to make sure that we drain one node, update the service, or update the file, and then restart the service. Using serial within our play will allow us to do that, where it'll run on one host at a time. So at the top level of our play, we just define serial equals any valid integer, in this case 1, but depending on how big your clusters are, you might want to do more than one at a time. Actually, don't do that. And then, so here we have the same task 1, 2, and 3, but it's going to run task 1 on node 1, 2, and 3, and then it's going to run task 1, 2, and 3 on node 2, and I cut off the screenshot, but it also did it on node 3. So then we take node 1, we can drain the node, update the file, restart the node, everything's good, move on to the next one, and we can have this rolling restart of the cluster that is safe. Before we do anything with changing cluster membership, when we drain nodes and restart them, that does change cluster membership. They're taken out of Raft. So here we need to make sure that before we make any changes, that those nodes need to be in an up and normal state. I wrote a role within our playbooks that we could use in multiple different places. That's outside the scope of this. But it essentially did this, and we'll see this in the demo. So again, I'm using another module called the command module. So I can just pass any valid Linux command to the command module, and it will run the Linux command as is on the system. So node tool status, we'll see this later in the demo. I register the output, so taking that return, saving it to a variable. And then in this case, I can look for anything in that, that dot standard out. So if I find anything as standard out that basically does not equal up and normal, I'm going to fail this task because I can't make changes to the cluster if any one of those nodes are down. I have a bigger problem. Hopefully I'm monitoring or something else in place that's telling me those nodes are down. I'm going to go work on those nodes, bring them up, and then I can go working on with my regular maintenance tasks here. Ansible has a great ecosystem. There's tons of automation. There's all kinds of things that you can do with Ansible. And that's my next tip is when you're developing playbooks initially or you're starting out using Ansible, running the open source CLI is fine. I'm about to demo the CLI. But in production workloads, especially you have a lot of machines and you need to really scale or maybe have compliance issues or concerns, finding some way to run Ansible and automation is really going to help you out. You can run playbooks on a schedule, you can have auditable output, and this is something that I think is really important when we talk about environment observability. If I run a playbook locally and maybe making changes in the cluster, but the rest of my team is not going to have a visibility. They don't know when I ran it or what I ran and what was the output of that. If we use another tool that we can go and take a look and say, oh, this job ran here and here's the output, That's just really going to help the entire team to have observability into the system. So lots of options out there. You can kind of build your own with your current CI tool. Jenkins and GitHub Actions are also great examples, or great ways to use this. When I first started using Ansible years ago, we just had a whole new stage in our Ansible or in our Jenkins file that just called a whole bunch of Ansible playbooks to get work done. The Ansible automation platform from Red Hat is Red Hat's paid version of Ansible, and so you can get subscriptions for it. There's different things that you get with as far as support or anything like that. And then AWX is like the free and open source version of that. So if you think about Red Hat or the automation platform as like Red Hat Enterprise Linux, and AWX is like Fedora. I have used automation platform at a previous employer. It was awesome. It's very easy to use. AWX we had at the DSP, and there's just a Kubernetes operator. So we had a whole bunch of clusters laying around. Carving out a new namespace and just installing the operator and using AWX was a really great way to use Ansible and the automation around it. Then there's a whole Ansible ecosystem that I haven't even had a chance to dig into in this talk. So there's the collection index and there's Ansible Galaxy. So be sure to pull in other code that you can use. This is just the top of the list for the Ansible collections index. We see AWS, we see Windows, there's Azure components, there's Cisco routers. If something talks over SSH or WinRM or has an API, Ansible probably can talk to it and you can use Ansible. And then here Ansible Galaxy, we can pull down other packages from the community. Demo time. All right. So we have here in VS Code, and I'm using a task runner called GoTask. So we see here we have a bunch of containers that are running. So I have a 3-node Scylla cluster. I have my actual Go gRPC service. That's my demo app. RoboClient is exactly what it sounds like. I'm just simulating user traffic. It is calling the RPC methods from the Scylla, or excuse me, from the server itself, and it's just hitting that server as fast as it can. The server exposes 2 RPC methods that essentially come down to a read request and a write request to the database. And then finally, this controller up here, this is where I have Ansible installed and where I'll run it so I can take advantage of Docker networking and service discovery. The repo is pretty simple. I have a 3-node cluster. We can see them here. I'm using local cluster DNS names to access them. And then here's our playbook. And I'll be demoing exactly what we've talked about. We're going to run a play with type 0, so I'm going to run against all hosts in my inventory. I'm going to run it one at a time. And so first thing we're going to do is, just like I said, we can't make changes unless all the nodes are up and available. Then we'll just debug the output so we can see what that looks like. If we made it this far and haven't failed, we'll drain the node, make sure the node is actually drained, then update the config file. So in this case, we're just assuming that there is a line that begins with foo, and then we'll just replace that line with foo equals bar. We're just assuming that this config item is there, and if not, we just create it. Then we'll restart the server, and then make sure it's up and make sure everything is good before we move on to the next ones. All right, so we actually have here. So let's take a look at the output of the server. So you see the log output. So it's moving very quickly, as fast as that client can run it. That's how we're responding. Maybe we might see some errors in here. We might not. So we just try to look for the errors flowing through there. So when we call Ansible, we need Ansible playbook-i. So the Ansible-playbook is our entry command, -i, and we have inventories, production, and then we're going to call that update playbook. So it's going to run this on the first node. It's going to check the cluster membership. All the nodes are up. We see 3 up and normal, so it's going to drain the node. At this point, I'm looking to see if we see any errors in the log output. This is when they would happen. Update the config file, restart the node, check that it's up. Checking cluster membership again. And looks like it's up. Moving on to node 2, check cluster membership, make sure all the nodes are up. They are. It's going to drain the node. check the node status. There we go. We updated the config. We're going to restart the service. Not seeing any errors in the log output. And then finally running this on node 3. So what we did is we checked, made sure all the nodes are up, brought one node down, updated the config, brought the node back up, made sure that everything was healthy, and moved on with the rest of our work. Thank you very much for attending this talk. Please reach out to me with these places, and also that QR code will take you to the code repo where you can see all of this. Thank you very much for your time, and I hope you enjoy the summit.